Welcome to Mathematics Academy. So in this video, I want to take you through modular arithmetic. So modular arithmetic is a kind of arithmetic that follows a cyclic event where a particular number keeps reoccurring after a particular interval. In modular arithmetic, we pay attention to remainders. But to understand modular arithmetic, the first thing you need to understand is what we call residue. And then another thing you need to understand is what we call modulo. We are in modulo 6. The residue solution. So residue of modulo 6 of mod 6. So the short form of writing modulo is mod. So when I write mod, now I'm referring to modulo. So the residue of modulo 6 are, so we have 0, 1, 2, 3, 4, and 5. So long modulo 6 is concerned, whenever we touch 6, 6 is something as 0. Okay, so 7 is something as 1, 8 is something as 2 under modulo 6. So these are the residue of modulo 6. 0, 1, 2, 3, 4, and 5 under modulo 6. The residue of modulo 4 is going to be 0, 1, 2, and 3. And the residue of modulo 2 is going to be 0 and 1. So let's take the next example. For example 2, we're asked to evaluate 37 mod 7. So we're in modulo 7. Of course, in modulo 7, the residues in modulo 7 are 0, 1, 2, 3, 4, 5, and 6. So this is 37. So we want to find the equivalence of 37 in modulo 7. So I will say, but 37 divided by 7 will give us 5, remainder 2. So therefore, 37 mod 7 is the same thing as, this is a symbol for congruence or equivalence, is something as 2 mod 7. So we did 37 divided by 7, the quotient is 5, and the remainder is 2. So our answer is going to become 2 modulo 7. So let's take another example. This example number 3, we're asked to show that 64 mod 5 is equals to 39 mod 5. So we proceed as follows. Solution. In 64 mod 5, but in 64 mod 5, but 64 divided by 5 will give us 12, remainder 4. So this implies that 64 mod 5 is equivalent to 4 mod 5. Similarly, in 39 mod 5, but 39 divided by 5 will give us 7, remainder 4. So this also implies that 39 mod 5 is equivalent to 4 mod 5. Alright, so since 64 mod 5 is equivalent to 4 mod 5, 39 mod 5 is equivalent to 4 mod 5, so this is equal to this. So therefore, we can conclude that 64 mod 5 is the same thing as 39 mod 5. Alright, so let's take another example to illustrate another way question on modular arithmetic can come. Okay, so this is modular addition. We are asked to add 18 plus 15 modulo 4. Okay, so solution. 18 plus 15 will give us 33. So this setting as 33 modulo 4. And then, but 33 divided by 4 will give us 8, remainder 1. So therefore, 18 plus 15 in modulo 4 is equivalent to 1 modulo 4. So modular addition is very simple. Just add the two numbers and then reduce it to its equivalence in that modulo. Let's take another example. This is example number 5. We're asked to find the positive equivalence of minus 35 modulo 4. So the goal is to convert this number from negative to positive. So the idea is to use negative integers to multiply the modulo, the 4, until we get a number that is immediately below this number. That is to say, we're going to be testing negative integers. Minus 1 times 4 will give us minus 4. Minus 2 times 4 will give us minus 8. Minus 3 times 4 will give us minus 12. Minus 4 times 4 will give us minus 16. Minus 5 times 4 will give us minus 20. So we'll keep testing. Minus 6 times 4 will give us minus 24. Minus 7 times 4 will give us minus 28. Minus 8 times 4 will give us minus 32. Not yet there. Minus 9 times 4 will give us minus 36. So I'm going to write minus 35 to be equal to minus 9. Minus 9 times 4. So minus 9 times 4 is going to give us minus 36. To bring back the number to minus 35, I'm going to add 1 to it. Remember, minus 9 is the first negative integer that I multiply with 4 that gave me a number that is less than minus 35. So minus 9 times 4 will give us minus 36. To make back minus 36 to become minus 35, I'm going to add 1 to minus 36. So because 1 was what was added, then it simply means that minus 35 modulo 4 is equivalent to 1 modulo 4. So that number that was added becomes our answer. So minus 35 modulo 4 is 1 modulo 4. So let's take another example. So in this example 6, we're asked to evaluate 10 minus 29 modulo 6. So I'm going to proceed similarly like we do in normal arithmetic. Of course, solution. Ten minus 29 will give us minus 19 modulo 6. So because it's negative number, we are going to proceed to convert it to positive. So, but minus 19 is equal to, so we're modulo 6. We're going to multiply 6 with negative integers until we get a number that is immediately less than minus 19. So let's go. Open our bracket. So minus 1 times 6 is minus 6. Minus 2 times 6 is minus 12. Minus 3 times 6 is minus 18. Not yet there. Minus 4 times 6 is minus 24. So that is the first product that is less than minus 19. So what we're working with is minus 4 times 6. So minus 4 times 6 is minus 24. So remember what we had here was minus 19. So what must be added to minus 24 to increase it back to minus 19 would be plus 5. Because minus 24 plus 5 will give us back minus 19. So therefore, our answer becomes 10 minus 29 in modulo 6 is equivalent to 5 modulo 6. So this becomes our answer in modulo 6.